Welcome back to Skill Talk. Let's continue our thermography series. And today we are taking one step further. We will be understanding that about the electromagnetic spectrum. What is this electromagnetic spectrum and why it is necessary for thermography, and how we can see the heat that is dissipating out from an object, right? So let's first discuss about the electromagnetic spectrum. I believe that we have already you all have already aware about this electromagnetic spectrum. We normally read about this in our school time. So in the electromagnetic spectrum, it's the range of all possible electromagnetic radiation. So it starts from long wavelength, that is the radio waves, until the gamma rays, that is having the very short wavelength. So normally our eyes that able to detect the visible light is range is from between 0.4 to 0.7 micrometer in this spectrum, while the IR rays that our thermography camera is detecting, it's lie beyond that, beyond the visible light. That is, its wavelength starts from roughly somewhere around 0.7, it goes up to 1 millimeter, or you can say the 1000 microns. So further, this IR waves are radiation is also divided into 5 groups. So one is NIR, that is the near infrared. So this near infrared is having the wavelength is between somewhere around 0.7 to 1.4 microns, and next one is the SWIR, that is the short wave infrared. So that lies from 1.4 to 2.5 or 3 microns, and the next one will be the mid one, that known as the MWIR. It's known as the mid wave infrared. So that lies somewhere around 3 to 8 microns, and the next one will be the fourth one will be the long wave infrared, that is also known as LWIR. So it lies from 8 to 15 microns, and in the last, that is the far infrared, that is above 15 till 1000 microns, or you can say the 1 millimeter. So normally that the thermography cameras that we are using, it detects it works somewhere around medium and long wave infrared, right? That is MWIR and LWIR. So the range that this thermographic camera are working is somewhere between 3 to 15 microns, right? So why it is so? Because normally the atmospheric gases like water vapors or the CO2, it's absorb less IR energy in these bands. So that's the reason. So in the mid wave and the long wave infrared are very less absorbed or very less disturbed by this normal environment gases, that is the water vapor and CO2. That's the reason that why we are using thermography camera in these ranges. Okay, so it is allowing us to have a clear thermography image. Okay, so this is about this is the complete discussion about the electromagnetic spectrum. So now let's move to the infrared radiation. So what is this infrared radiation? So as we have already discussed in our last video, that all objects that are above absolute zero, and what is this absolute zero? Is 0 Kelvin. Okay, 0 Kelvin, that is equals to minus 273.15 degrees Celsius. Okay, so all the objects that are above absolute zero, they emit the electromagnetic radiation, and this radiation can be because of maybe some vibration of the particles or the molecules inside that object, or maybe the friction or the movement of their molecules, right? So as hotter the object, so the more intense the radiation will become, and the shorter its wavelength. So that means we will discuss this thing later on after discussing the physics law that is related to the infrared radiation. Okay, so let's discuss about the two main physical laws. So first one is the Boltzmann law. So what is this Boltzmann law? That the total energy emitted per unit surface of an object is directly proportional to the fourth power of its absolute temperature. Okay, so that means that very small temperature difference can cause and can emit a very huge radiation, right? So, and the second one is the displacement law. Okay, Wien's displacement law. So as per this law, the wavelength at which that object emits the most radiation, that will be shifts inversely with its temperature. That means hotter the object, that means short wavelength. Okay, so hotter the object and short wavelength, and as cooler the object is, that means more wavelength. Okay, so let's take one example to clear this. Let's say we are a human and our temperature normally is somewhere around 37 degrees Celsius. So if you Google it, you will find that our electromagnetic wave that we are generating, that is somewhere around 9.3 micrometers, right? And after that, once if you will see any kind of metal or that is heat up to 1200 degrees Celsius, so you will find the wavelength of that metal will be very, very short. That will be somewhere around 2 to 3 microns. So I think it's very clear that what is this Boltzmann law and what is the displacement law. Okay, so let's move to the next topic, that is the atmospheric transmission and the IR window. IR window means infrared window. So since we know that in our Earth's atmosphere, okay, all the IR wavelength are not allowed to pass because of the protection that we are having in our Earth atmosphere. Okay, so the gases like water vapor, or you can say the carbon dioxide, and some specific range of IR energy is absorbed by the ozone that is surrounded to the earth, right? So it will create a one kind of a atmospheric absorption band. Okay, so between these absorption band there are some IR transmission windows. Okay, so these transmission windows lies between 3 to 14 microns. So that is the only window that we have, that from where IR can pass through and our thermography camera can detect. That's the reason that why thermography camera is only detecting the wavelength between 3 to 14 microns, or you can say the medium wave and the large wave infrared. Okay, so that's why it's very important to choose the right IR camera. So how you will be choosing the right IR camera depends on the application and also the IR configuration. So what is the IR camera configuration? That depends on the target that you are monitoring. So what is the temperature of the target and what is the viewing distance, okay, between your camera and that target, and the third thing will be the environmental conditions. So what are the environmental conditions that you are measuring, or you are doing the thermography in a very hot, or in the daytime, or in the night time, or what is the humidity level, okay, whether it's a dusty environment or it's a rainy environment. So depends on that. Okay, so now we will move to the another section, how IR camera can see the heat. So whenever you are planning to take an IR image of an object, so the first thing that come in your IR camera is the lens. So this lens will you will be focusing with the help of this lens to that object, and that lens will only allow the certain wavelength of IR through it. Okay, pass through it. So what is that wavelength? We have already discussed before. The wavelength lies between somewhere between 3 to 14 microns or 15 microns. Okay, so after that this image, this you can say this IR light will fall on the detector that is just behind this lens. So this detector will convert this IR energy into the electrical signal, and these signals will be processed inside through the circuit to convert into the thermal image, where what happened that each pixel that represents a temperature measurement. Okay, so this pixel size is completely depend on the resolution. Okay, so after that what happened that we are using the color palettes, and these color palettes are if falsely applied, then definitely there will be we will not able to differentiate between the actual color of an object. So the important note here is this, that IR camera do not measure temperature directly, that we have already discussed in our last videos. So they measure the IR radiation that is emitted, reflected, or sometimes transmitted by the other object. Okay, so these are the only three radiations that we are going to get in our IR camera. One is emitted through the object, second is the reflected by the object, and third one is the transmitted through that object, and then it will calculate the temperature using the algorithms. Okay, so now let's summarize everything. What we have discussed is that IR radiation is invisible to our eyes. Why? Because the wavelength of IR is beyond our eye limits, but if we have right understanding and if we are having a right IR tool with us, then we can use it to detect the heat patterns, and we can diagnose the faults and improve the reliability of a machine, or you can say that particular object or the entire plant. I believe the topic is well clear, and if you like this video, then please make sure to like, subscribe and share this video to help grow the Skill Talk community. Till then, take care of yourself. We'll meet in another video on another topic on thermography, and please remember, at Skill Talk we are turning skills into power. Thank you. Meet you later. Bye.